Welcome to lesson 16. Have a go in your own time, usual thing. Right, here's my answer. According to me, x is 9. So you can just skip if you like, be more to listen to this, which is just to say, lesson 16. We're now settling into the last few lessons. It's going to be a lot of repetition now, just kind of drilling what we've learned, trying to get really solid with it, so nothing much new. There's one crucial bonus lesson coming up, which is going to be a bonus lesson attached to lesson 18. And that's going to have a little advanced kind of discussion point about something we're doing. Otherwise, hopefully this is going to start feeling like nice, okay, just kind of get comfortable with what we learned. Anyway, moving on. Right, here's my answer. I'm going to use look the same. Which means I'm going to keep this as root 4x. Remember my general rule, which is if there's kind of a letter there, maybe you want to change the number, like make the number look different. So we're going to make the 6 look different, so that would be square root 36, wouldn't it? There you go, that works. So then we can say, by inspection, the insides of these two must be the same. So 4x must be equal to 36, divide by 4, and we get the answer. Let's do the next question. Have a go in your own time. And the answer is not possible. Because there's two variables and one unknown. You might have rearranged it. You might have say multiplied by q and said, well, p equals q over 2. Just to say that's a bit neater. At least we've got one in terms of the other. Yeah, strong answer, but not possible in the context of what we've been learning during these lessons. Not possible is kind of what I was looking for. I'm making that a bit messy. Let me just tidy it up a little bit. There we go. Have a go in your own time. I'm going to say there's two possible answers to this. One possible answer is to say that q, let me try and write again, q equals minus 1. Because we can actually work out what q is. Or you might have just said not possible, because you might have said, well, there's two variables. In fact, there's 3 variables, aren't there? Because there's an x and an x squared and a q. There's only one equation. But here's the thing. We've kind of talked about this before. There's some brackets. Well, there's nothing to lose here. Why don't we multiply the brackets? Because if it's not useful, it's not useful. But it might be useful. So let's multiply the brackets and see what happens. Okay. Let's look at this. Okay, let's use the technique look the same. Which is always a good thing to do because this is a version of simplifying, this is a version of tidying up. I'm going to make it so the x squared's at the start, which is actually one of the things you learn when you're at what I learned when I was at university, namely that if you're doing whenever you've got equations, you should always line them up with x squared x and numbers, or x cubed x squared x, because it enables you to see answers which you wouldn't see otherwise. Because now look at this. Hang on a sec. That q must presumably q's minus 1. Let's just check it well on the other side. Let's use black. Got a 5 here. We've got a minus 5q. So if we need to check that these don't contradict. 5 equals minus 5q. Divide both sides by 5. 1 equals minus q. Times both sides by minus 1, or however you want to do it. Minus 1 equals q, so q equals minus 1. Yep, they don't contradict. We can now confidently say q is minus 1. Which means we could now put that minus 1 in, but then we're going to realize we can't find out what x is. But we can at least find out what q is. So that was interesting. Maybe the key thought there was, we have been kind of talking about this already. If you can see something that you could do, you can try and just see what happens. Next question. Have a go in your own time. And We drop a line down, one of the two must be equal to 0. Plus 4, x equals 4, minus 1, x equals minus 1. By the way, did you try and multiply out the brackets? You might be thinking, wait a sec, Duncan just said it's a good idea to try multiplying out the brackets. Well then why isn't it a good idea here? It isn't a good idea because you have to remember the trick. The trick being if there are two things multiplied together that equal 0, then you've got something just to go with straight away. I wasn't very clear there, was I? There's a few of these equations, so let me just write all these out. Here we go. Can you solve this situation? Right. The answer is a equals 4 and b equals 4, or a equals minus 4 and b equals minus 4. It's one of the two. Should we have a go and see what happens? I just want to check something. If I take this equation, I've got two a's, because it's like an imaginary plus there, so that's 2a. And then there's minus 2b's equals 0. So equation 2 and equation 3 are exactly the same. So let's just ignore that one. That's not useful. Next thing. Well, what about if we take this equation and we add 2b to both sides? Then we get 2a equals 2b. Then we could divide by 2, and that gives us a equals b. Well, that's got to be useful, hasn't it? So now we could, let me find a new colour, we can take this, we could put it into here. So that then gives us a plus a equals 32. So let's work from there. That means that 2a squared, are we happy? Let's just do this a bit slower. A squared plus a squared, because remember a times a makes a squared. So that means that 2a squared equals 32. So now we divide by 2, which means that a squared equals 16. So a equals, so if we square root both sides, a equals square root of 16, which equals 4 or minus 4. So in the case where a equals 4, then b is also equal to 4, because we know they're the same. And in this case, b is equal to minus 4, because remember they're the same. Hence, the two answers that I mentioned earlier. So that might have been difficult, but remember, all I've done is I've just plugged away, and it looks confusing, but like this equation here, I just identified early on, I'm going to start with this equation here, the 2a minus 2b, because it just looks like the easiest one, and then I fiddled around with it. Oh, a equals b, so I can put it in the other one. Let's do the next question. I'm just going to start drawing my axes straight away. Now the answer is this. How do I know? Because I draw a table, x and y. What if x is 0, y is 1? What if x is 4? Square root of 4 is 2. And so on, we can end up with this line. What if x is minus 1? Or minus 4, let's say minus 4. What's the square root of minus 4? It doesn't exist, it's not possible. So, it doesn't exist here. It only exists in the top right hand section of the graph. To draw a graph, you just need to draw a table and do it that way. Have a go in your own time. The answers are y equals minus a third, or y equals minus 1. I'm now going to go through my answer. There's two different variables. There's a y squared and a y. So in theory it's not possible, but I can because I can use the trick, which is I can make it two things multiplied together because I can see a squared and a normal. So it's going to be like this. Well, I can immediately see that it must be plus 1 because 1 times 1 is the only way of making 1, which then means, remember, we've said before, you have to have a y and a y. You can't split that up. So it's just a question of how do we make the 3? Well, there's only one way of making 3. It's 1 times 3, so it must just be that, surely. And if you like, you can multiply out to check. That is definitely correct. We drop a line down. One of these two must be equal to 0 because two things multiplied together are 0. Therefore, one of them is 0. Minus 1, 3y equals minus 1, divided by 3, y equals minus 1 over 3. There you go, that's that one. Minus 1 from both sides, y equals minus 1. There we go. Let's do a calculate. There's a few of these. I'll let you know when I've finished. That's it, that's all of them. Have a go in your own time. Okay, answers are 1, 3/5, 2/9. I can't do this one. I'm going to have to do this properly. I'm going to make it so they're both over 6. So I'm going to times that by 3, times that by 2. So that gives me 3 over 6 plus 2 over 6, which is 5 over 6. There we go. That is minus 8. That is minus 1. That is 25 over 4. So skip to the next question if you like. I'm going to now talk it through. Let's put a plus 1 in front of that. I've now got a plus 1 and a minus 1 which cancel, which just leaves the plus 1. Remember, I can make that 3 over 1, which means we do 1 times 3 and 5 times 1 because that's how you multiply a fraction. Again, we can put that as 2 over 1. 2 times 1 is 2. 1 times 9 is 9. You've already seen me do this. I had to times the top and bottom by 3 and the top and bottom by 2 so that the denominator would be the same. Because remember, what's 1 elephant plus 1 giraffe? Don't know. You can't really add them together. What's 1 elephant plus 1 elephant? 2 elephants. You can combine things if they're the same thing. This is minus 2 times minus 2 times minus 2. Minus 2 times minus 2 is 4, because minus times minus a plus, and then 4 times minus 2 makes minus 8. This is minus 1 times minus 1 times minus 1 times minus 1 times blah 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 times 1. All of the pairs of minus 1 cancel to make 1, which means you just end up with a minus 1 at the end, hence the answer. Remember that minus means flip. So let's do that straight away. That gives us 5 over 2, but indices, our power is a series of instructions. We haven't done the second instruction yet, which is the 2. That means square, so that means you have to times it by itself. How do you times a fraction? You times the top by the top and the bottom by the bottom. There we go, that's the answer. Let's do the next question. Have a go in your own time. X equals 4, by the way. That's the answer. I'm now going to do it. I'm going to use look the same. And again, we're stuck with the... Here's the interesting thing. Yeah, we're stuck with the X. We can't really do much with that. Well, we kind of could actually, but let's just do it this way. There's a few different ways of doing this question. So I'm going to pretend that I've looked at that and thought, well, I'm kind of stuck with it. I'm going to put a pin in that and come back to it later. Which means I'm going to try and make this right-hand side look like the left-hand side. Well, I know this thing, root A, root B equals root AB. So what times what makes 8? 2 times 4 makes 8. Well then we've done it. Because by inspection, x equals 4. Done it. I just want to point out, we could have done it a different way. As I was speaking out loud, I realized we could also have said root 2 root x using the rule root A root B equals root AB, then that's just equal to root 2x. X is 2x. So that, this is now pretty horrific. Let's go down here. we can then say root 2 root x equals root 8, which means that root 2x equals root 8, which basically means by inspection, the thing inside must tell us that 2x equals 8. Divide by 2, x equals 4. Let's do the next question. If I can work out which the next one is, here we go. Solve. Have a go in your own time. Okay, how do we do this? There's two different variables, so in theory we can't do it because a K5 behaves differently to a K to the 4. Let's try and use the trick though where we factorise. How do we factorise? The first thing is we try and take something out on its own. We can take a K to the 4 out, which leaves us with K minus 3. We can then drop a line. We now know that we got two things multiplied together that make 0, so one or the other must be 0, so either K to the 4 equals 0 or K minus 3 equals 0. This means that just simply means that K equals 0. In this case, we add 3 to both sides, and that gives us K equals 3. Ta-da! That's the two possible answers. Got another solve question here. And this time I'll try and remember to write out the answer straight away. Okay, pause the video, have a go in your own time. The answers are x equals 0, or minus 2, or minus 3. I'm now going to do my working. Three different objects, an x squared, and an x cubed, which means in theory can't be solved because there's only one equation, but let's use the trick. Let's try and factorize. The first thing we do is to try and take something out. They've all got an x, so we can do this. Again, I'm just doing repetition of the same question because I think that's the easiest way just to learn, because we can then focus on big picture. Oh look, we've already taken everything out. The second thing we do is we try and then factorize with double brackets, which we can do. We've seen this a million times now, x plus 2, x plus 3. So we've now got three things multiplied together. One of those three things must be equal to 0. And they all involve x, so it's an or. That means that x equals 0, or x plus 2 equals 0. And if we minus 2 from both sides, we end up with x equals minus 2, or x plus 3 equals 0, so we minus 3 from both sides, which gives us x equals minus 3. Ta-da! Here's a function question. Again, I'm not really going to write a question, I'm just going to give a bunch of facts and you can just kind of fill in the blank. That's it. Have a go in your own time. Okay, answers are 9 minus 2, x over 2, 10k squared. I'll talk that through in case you want to hear it, otherwise you can skip obviously. Oh look, that's just dividing by 2. That's just dividing by 2. What's 0 divided by 2? It's just 0. So we just divide everything by 2. That works, doesn't it? By the way, what's 20k squared divided by 2? Oh look, those cancel and you just end up with 10. So it's just 10k squared. That's where that came from. Make Q the, what's the next word going to be? Subject. Have a go in your own time. The answer is Q equals x over 5. Right, here's the thing. You know when we're tidying up, we've talked about this before, we like to tidy up brackets. We like to tidy up fractions. So I've said this before, this is basically just mathematician knowing what to tidy up. The fraction. I don't like having the q on the bottom because the q is the thing that is supposed to be the subject. It can't be on the bottom, can it? So that gives us x equals 5q. Is q on its own yet? No, it's not, because there's a 5 with it. So I'm going to divide by 5, which gives me x divided by 5 equals q. So I'll just write it around the other way because I prefer to have q at the start. Q equals x over 5. That's the final answer. Last question. And there's going to be a bonus lesson on this particular topic. Oh, let me just check I've said that correctly. Yes, there is. So it's called factorize or simplify. This is one of my own kind of invented question types. Now the idea is you've got 4 things, and in each case either you can factorize it or you can simplify it. So you've got to decide which. And that's it. Have a go in your own time. And the answers are 10x, 2, 4x plus y, that's supposed to be a 4, 2x, 4x plus 1, and 10x squared. This is the last question in this video, so you can just finish this video whenever you like. This was a simplify. This was a simplify. This was a factorize. And this was a factorize. The idea with the first one is they both involve x's. There's 8 of them plus 2 of them, which makes 10. Here you've got an x squared and an x squared. They're both exactly the same, so you've got 8 of them plus 2 of them, which makes 10. This question here, you've got an x and then a y. They're different things. So I wonder if we can factorize. Well, we can, because I made the question like this. They both share a 2. So I took the 2 out, and then I did the factorizing thing. And if you multiply it out, you'll find you get the original. Same thing here. There's an x squared and an x. Remember, an x squared and an x are different things. So we factorize, but it turns out we can take out both the 2 and an x. If you multiply it out, you'll get back to the original. Thanks for watching. See you in the next video.